Hi everyone, and welcome to the ANSYS Fluent 2020 R1 update. Sorry, we had a little bit of technical difficulties, and now we're online. So I just wait maybe a few seconds for more people to join, and then we start the presentation. All right, everyone. Once again, welcome to the ANSYS Fluent update 2020 R1. I'm Sina Goetz. I'm a senior application engineer here at PDT, and I mostly take care of the CFD and switch to full screen here, and we go from there. Perfect. All right. For those of you who are not familiar with our company, company is Phoenix Analysis and Design Technologies, called PADT. It was founded in 1994 by four turbomachinery engineers working for Honeywell. Back then it was called Allied Signals, and our headquarters is based in Tempe, Arizona. We have offices in California, Colorado, New Mexico, Utah, and Texas. We have around 85 employees. We have three departments: numerical simulations, product development, and 3D printing. And in each department, we do sales, support, and services. In the numerical simulation department, as I mentioned, we do sales. We are an ANSYS retailer, we're an ANSYS Elite channel partner. We also sell Flownex, which is a kind of a system-level simulation tool. And we do technical support. We have a frontline product technical support team. We do training, and we do mentoring. We also do engineering services, or consulting basically, in different numerical simulation areas, from stress analysis, dynamics, fluid and flow, thermal, electromagnetics, and multiphysics. And as I mentioned, we are a lead channel partner for ANSYS, which means that we have a strong technical partnership with ANSYS. And we have an award-winning technical support team. We have a long-term relationship with many of our customers, more than 20 years for some of them. And one more thing before we talk about the Fluent updates. Just want to introduce you, if you've not been introduced already to the ANSYS Cloud. Just want to introduce you to the ANSYS Cloud, which basically provides users with an easy access to an on-demand HPC directly from the ANSYS flagship products and tools. And those flagship tools and applications are right now ANSYS Mechanical, ANSYS Fluent, and Electronic. And it has many advantages and benefits. And it's really easy to use. It's basically one click from within the software, within those tools. It's just a one click that you basically submit a job to the cloud, and you can, in a web-based service, you can do 3D post-processing. You can monitor the job and upload, download the results, and edit files. And it's highly optimized for ANSYS solvers. ANSYS is doing it in partnership with Microsoft Azure. So the main advantage of this partnership is that the users are provided with a single vendor that provides them with the solutions both for the software and hardware. And again, hardware is hardware is highly optimized for the specifically ANSYS solver. So as mentioned, ANSYS Cloud will deliver speed, power, and compute capacity to users when and where it's needed. And there are multiple scenarios that you can think of taking advantage of using cloud. One might be running some larger or more complex with higher fidelity and accuracy simulations to gain some insight of your product or to what you're doing. Not something that you necessarily do every day. And the other scenario can be like a peak of design, for example. It's like something that you necessarily do every day, but based on your design cycles, you might at some point, like once a year or twice a year, again, depending on your design cycle, you have a high demand from other departments or from designers to analyze basically their design. So it can be a very useful option or helpful option. And you don't necessarily need to have enough hardware for those peaks available to handle those type of scenarios. So if you're interested in this service, the cloud services, please contact us. You can see our phone number and an email, and you might be eligible for a free 30-day evaluation of ANSYS Cloud. With that, let's start jumping to the 2020 R1 Fluent updates. The first thing I want to mention before talking about the updates is the versions and names that ANSYS is going to use from now on. You're probably familiar or aware that the ANSYS switched from like 19.3 or 2 to 2019 R1, R2, R3 last year to just match the exact calendar year. And so this year would be 2020. And the big difference probably is that there's only going to be 2 releases from this year on. It's going to be 2020 R1, and then later mid-year it would be 2020 R2, both releases. And this is true for all the ANSYS products. So it's going to be a very consistent release naming. Different consistent versions basically, and all the versions are going to get developments and new features, as well as obviously if there's any bug in the previous version, it's going to be fixed in the newer versions. So for the 2020 R1, probably the most important or first noticeable change and update is that Fluent got a new launcher for all its Fluent workspaces. And it's basically a single place to launch different environments like Fluent meshing, solution, rising, and then we're going to add more environments to this launcher eventually. And another great good thing about this new launcher is that you can immediately launch different mesh or case files here. Don't necessarily need to launch to Fluent first and then import them. And another cool feature is that based on the case file or mesh file that you have read and imported here, the software would automatically select the appropriate dimensions and precisions. And it's something, if you remember before, sometimes you had a 2D problem, and then you by mistake, you might have launched the 3D Fluent measure or solution, and then you have problems. So it kind of fixes that here. As soon as you import or start with a case file or a journal file or a mesh file, and in a smart way adjust these settings for you. And then we have the parallel options or settings down there. The bottom left, if you notice, there's a show more option. It's very similar to the old launcher, more options. You can specify where to save the data and those things. And there's another drop-down option or menu showing learning resources that if you click on it, there are multiple blogs and documents that you can go through if you have questions. And then the second, probably noticeable and very obvious change is that now the task page outline view and consoles are kind of dockable. You can collapse them to give the window that you have, the graphics window, a more space to basically, if you want to visually investigate your problem, if you want to present it, it's basically a bigger graphics window for you to work with, and that again gives more advantage to the users when they're presenting or looking into models or results. There are a few new rendering effects. There's reflection, shadows, there's ground plane added, and other effects. And a good thing about these is that, so first of all, it gives the software kind of a new look, a fresh look, and if you're presenting a result, probably more impressive. But you have basically control over these. If you go to the preferences dialog box and then graphics, you'll notice that there are different options that you can uncheck the reflection, the shadows, and everything. So you have full control over that. Even besides that, there's like the kind of manual control. If you go, the software in SmartWay basically detects your hardware, graphics hardware available. And if you have enough graphics hardware, it will definitely, by default, switch to enhanced graphics. That includes all those rendering effects that I mentioned. And if there's not enough graphics hardware available, it will switch to a more limited rendering capabilities or enhanced performance. Kind of limits those new rendering effects, not to slow down your machine basically. There are a few improvements and enhancement in the meshing workflows, and for those of you that are not familiar with the Fluent workflows, it started mainly last year. Started really like late 2018, but the main development was probably 2019 that ANSYS introduced meshing workflows. And the idea of these workflows is that before the Fluent meshing task was not necessarily an easy task. It needed the user to navigate through different windows and know or have kind of a decent amount of knowledge about the Fluent mesher. So ANSYS introduced these new meshing workflows that enabled the users without necessarily having decent knowledge about the Fluent meshing. Step-by-step guides them through the Fluent mesher and helps them to get decent results out of the Fluent mesher. And at each task, at each step of this workflows, the users are basically software suggests just the meaningful and relative options to the user, so minimum distraction. And really easy to go from top to the bottom of these workflows. So I would suggest you to try these if you want to use the Fluent mesher. It's really easy now to use. So now in 2020 R1, there's some updates and enhancements. And one more thing to mention is that there are two main meshing workflows introduced previously in 2019. One was called Watertight geometry, which is basically you start meshing with a watertight and kind of clean geometry, and the other one is the fault-tolerant workflow, which you don't necessarily have in watertight or clean geometry. There are some gaps or missing cases that you can work with or start with to mesh. So in both workflows, now you have a full boundary layer flexibility, and that was a big kind of a constant request from the users for a long time, that they wanted to have flexibility. before you kind of had a global boundary layer setting. So you set up the boundary layer, used to set up the boundary layer, and it was applied to all the walls and all the regions basically. Now with this full boundary layer flexibility, you can have local boundary layers, and it can be applied to different parts of the model. It can be applied to different walls, or only walls, just fluid regions, or just solid regions, or the interfaces, main regions. This is something very useful. So basically, you can have different, from the pictures, you can see different boundary conditions applied to different regions with different settings, different number of layers, different resolutions. So it's something that I know that many users are looking for. And some specific enhancement to the Watertight workflow. And now it handles a non-symmetric periodicity, and it stores the location of zones for persistent meshing, and probably if you're a Linux user, there's a bottleneck before, because there's no SpaceClaim right now is not accessible or compatible with Linux, so Linux users had problem importing the STDM, which is the SpaceClaim format files into the workflows, and now you can export a PMDB, which is Part Management Database, from SpaceClaim, that it's going to basically be used as a workaround of that problem. You can optionally use a size build in your volume meshing, if you're familiar with that concept, and there's an automatic draw of bad volume cells now in the Watertight meshing workflow. In the other workflow that I mentioned, Fault-Tolerant, which is basically their geometry workflow, there's an enhancement. There's a task introduced to update the boundaries, similar to the Watertight geometry. And now there is, in the local refinement region task, there is an offset box that you can create a scaled or offset based on the bounding boxes that you have. So these are very useful techniques that you can use for if you have like external fluid dynamics with vortex settings, and you want to capture or have different refinement regions to capture those effects, for example. And also now you can identify the deviated faces, and there's a step and task for that. And before, if you've used this Watertight or fault-tolerant meshing with the wrapping technology, you know that the generated mesh might deviate from the actual geometry. And before you need it to be in the solver environment, not the mesh or the Fluent solver, to check those deviations. Now it's in the measure step, basically, or environment, that you can check how accurate is your mesh in terms of being on top of the solid your CAD geometry. There's also another option, part per body. So if you have, for example, in the SpaceClaim, assembly or solid with different parts, and now there are two options. You can import it as one part, or you can have all those basically multiple bodies of that you have in the SpaceClaim imported as different parts in the Fluent mesher. Now let's talk about some setup enhancement in the 2020 R1. This is very useful. This is something if you've used like ANSYS Discovery Live or AIM, it's something that is available there for kind of a simpler tools, and now it's available in Fluent. And the idea is that you can click basically on different zones in the graphics window, and there's like a quick menu that appears with the most common boundary conditions. So it's really easy to set up a quick setup for those boundary conditions, like velocity and lead. Multiple boundary conditions you can set up together. If you click on the more, it basically opens the boundary condition dialog box that used to be the case before, and users are more familiar with. There's also an enhancement in the multi-edit boundary or cell zone dialog box. If you remember 2019 R3, this was introduced first by ANSYS. So you can select basically different zones from the zone list, and then you can change them, their properties altogether, or copy from the master zone, the properties from the master zone. You can copy that or apply it to the rest of the zone list that you've selected. There were some bottlenecks before. So in 2019 R3, as you can see in the image, like if you select multiple zones, the first zone by order, like the top of the list, whatever you have selected, was considered as the master zone, and then you only were able to see the properties of that zone or copy those properties to the rest of the list. Now, in the 2020 R1, there's a drop-down menu added that you can basically define what is your master zone. And this way, you can basically change the master zone. And the second advantage is that you can see the properties of all the items that are selected zones in your list. So it's more control over the multi-edit option that was previously introduced. In the physics modeling, also there's some enhancement. Probably is one of the biggest ones is the turbulence update. If you remember, before in Fluent, the default was a laminar flow in terms of the turbulence model or option. By default you had it was laminar. Now it's switched to by default the model is K omega SST, and there are two reasons behind it. One, 99% of the CFD simulations are not laminar. Basically, the actual or the fluid dynamic problem that you're trying to solve is not laminar. And the second reason is that it's ANSYS wants users to switch or migrate slowly from K epsilon, which was probably the most common or most preferred option before among the users. ANSYS wants the users to slowly switch to the K omega SST because it's more accurate and more capable in many cases, including the separation. There are some cases still might be the K epsilon a better option, or few cases I would say. So in general, K omega SST is a better option. And there are some cases that K epsilon might be more stable. There are some ways to basically switch back or use K epsilon in those cases. But this is safe to say that K omega SST is a good option to be a default for the turbulence model. Also, the buoyancy effects, which was previously only available in epsilon-based models, is now available in the omega-based models. And there is a synthetic turbulence has been extended for SDS model with volumetric formulation, and this is a problem. Before was that if you had like acoustic simulations, this synthetic turbulence formulation was applied to the faces that used to cause some problems, and now they can be applied and they have a volumetric formulation basically not to generate those issues with acoustic simulations. In the Eulerian multiphase, there is a workflow consolidation. So before, if you remember, if you had a multiphase problem, you had to kind of set up the whole required inputs in three different dialog boxes and windows. First, in a top level, you had to select from the multiphase model that it's multiphase problem, basically, or Eulerian multiphase problem. And then in the phases dialog box, you needed to define the phases, and then the phase interaction needed to be set up in a different window. An interaction means the mass, momentum mass, and heat transfer exchange, basically, or heat exchange. Now everything is consolidated in one dialog box in 2020 R1. You can access it. You can open that dialog box from a ribbon or the outline view, and each of those dialog boxes are now basically here presented in different tabs. You have the model tab, phase tab, and phase interaction tab, and a population balance also is now fully integrated in the multiphase workflow. basically that if you want to divide them into different distinguish groups and monitor their behavior, basically. Volume of fluid, or VOF, has got some enhancement, and this is really a feature I like. And then now, if you want to do some mesh adaptation, there are some predefined mesh adaptation controls for volume of fluid and volume of fluid to DPM that basically automatically sets those registers and applies them to the different regions of the domain. Depending on what you select, if you just select volume of fluid, then those refining coarsening criteria would be based on just the volume fraction gradients. If you select the volume of fluid to DPM or VOF to DPM generic, it would be just basically the proximity of the interface. And a more advanced one, it would be both the proximity of the interface and the cell size threshold inside the secondary state. That's how, if you think of it as like a breakup problem, for example, is that how big are those droplets that you have and how you want to refine the mesh around those. So it's again very, it's going to save you a lot of time if you take advantage of these mesh adaptations. Here's some multi-phase robustness enhancements. For buoyancy-driven multi-phase, now you can basically model the operating density using new options, which before there was only one option, which was the minimum density of the phases. Now you have that option as default, but you can have like primary, phase, or a mixture average. And also there are two new text commands to use to preset to the volume of fluid cases to optimize basically the setting for better stability and robustness. And there's another basically the command that you can use for more stability for multi-phase problems, and their documentation for that in the new release notes. In the DPM, there's a high resolution tracking method, which is an alternative particle tracking approach for cases that you have small particles, for example, with low relaxation time. And this method basically decomposes the cells into their tet components. They're called subtets, and then tracks the particles through those subtets, knowing that how those subtets are connected to each other, and they do constant continuous interpolation basically among those subtets. So it makes it really more efficient to track particles in this way, more accurate, and it's compatible with most DPM capabilities. There are some exceptions, like Overset match is not supported with this method yet. And if you have a breakup problem and you're using the Madabhushi breakup model, there are some extensions to that. You can now have there's a new column for the drag coefficient parameter, which by default is 1.48, and you can have your UDF function as the drag log, which is something that many users, advanced users, have asked for a long time. If you have a Lagrangian wall film patching, basically representing the wall film with particles, there are some enhancements. You can now initialize the wall film, basically. So in your wall zone setting, as you can see on the right-hand side of the screen, there's a tab, a DPM tab associated with that wall. That if you check the initialized wall film, there are some options to use as your initialization input. It can be a wall film height, a wall film velocity, film temperature, and minimum number of particles per phase, and minimum film partial surface density. And The minimum film partial surface density is an option. It's a good option. Minimum number of partials per phase. Sorry, is a very good option if you have a very non-uniform mesh, basically. So it will help you to have or distribute the particles as representing the wall film. You can initialize from injection, so it's used to assign injection materials to corresponding physical properties of the film. And in addition, you can reset this Lagrangian wall film to 0 from the solution resolution task just by clicking on the reset button. And this will just delete all the Lagrangian wall film particles as well as zero out the corresponding first phase variables without affecting the free stream particles. So it just affects the particles associated to the wall film, not the whole domain. There was other applications that has got some improvement. One of them is this gravity-driven falling film. So on the right, it's representing the pictures representing the kind of a liquid like a water and oil falling on a surface, and as it moves down under gravity, there's some instabilities, the capillary instabilities and waves growing that before it was not, the software was not able to capture because there's a film height and momentum coupling that causes this effect, and if you don't have that coupling, you're going to miss that, or you're not able to capture that. So now, if you use the coupled solution approach, this you can basically capture these film dynamics as showed in the images on the right of the screen. So again, very specific physics and application if you have wall films under gravity that you want to see those details of the capillary waves. Radiation has got some improvements, specifically the Monte Carlo can specify now both the diffuse and direct boundary source for the Monte Carlo. And before, if you had an irradiation, usually those values were parallel to the beam. And if you had the component normal to the surface, the user had to kind of back calculate the parallel to the beam value, and now it can be done automatically by the software. In the acoustics, the far field acoustics, there's a new Kirchoff integral for acoustic wave equation solver, which basically enables the users to use any closed surface as an integral surface. And before it was kind of a bottleneck because there was those integral surfaces needed to be only the zone surfaces. Now it can be any closed surface using this new integral method. There are some restrictions. Probably the most important one is that this is only an on-the-fly computation, so meaning that you cannot save the data and post-process these acoustic properties later. So it's kind of an on-the-fly calculation. In the fluid-solid interaction, the structure model has got some improvements, specifically the non-linear elasticity. You can now, which accounts for large deformation, now you can have non-linear elasticity, basically that detects the stiffness matrix. And now there is a compatibility with the wedge and pyramid cell types. And von Mises equivalent stresses is now available as the post-processing quantity within the Fluent post-processing. In the solver enhancement or some numeric enhancement for the numerics enhancement. And this is one of my favorite new features is that you now can have multiple reference pressures. So you know that reference pressure is used to prevent gauge pressure from floating in incompressible flows without pressure boundaries. Before, just imagine a scenario like on the one on the right side of the screen. Before, if you had multiple fluid regions, first of all, you were only able to identify one reference pressure, and then if you have a pressure boundary condition anywhere in your domain, that reference pressure would be overridden by that boundary condition, pressure boundary condition. Now, again, this scenario on the right is showing you three different volume regions or fluid regions. One has a velocity inlet and pressure outlet, and then there's another one, two basically regions that are that have walls, one moving wall and fixed walls. So three different volume or fluid regions. Now you can specify reference pressure for those two regions that are bounded with the walls. And the one that has pressure outlet, as I mentioned, doesn't need any reference pressure because it's going to be overridden by the pressure outlet. But this is basically a good improvement that you can have now, different values for different regions. And this one-to-one automatic interface pairing. So if you remember, 2019 either are 2 or 3 ANSYS introduced this many-to-many interface pairing, and the idea was that if you have a region, for example, the yellow box in the image that you can see on the right, that is in contact or has interface with the green box, the pink box, and the ground, and also the fluid around it. So when you had multiple interfaces, the software were able to detect these multiple interfaces and basically make it very easy for the user. Or some problem was that if imagine that the yellow box only has all the faces of the yellow box are a one wall boundary, basically boundary zone, represented by only one boundary zone, one wall. In order to detect all these interfaces, the user needed the measure level to kind of define different surfaces and then mesh them as a separate surface meshes, and then define or let the software detect these different interfaces. So it was very, first of all, time-consuming, and the second issue was that it was not compatible with the polymesh. Now it's fixed, so you don't need to basically break it down to multiple faces to detect these multiple adjacencies and interfaces. It will automatically detect all these adjacencies and interfaces, and now you can apply different interface conditions and settings to all these different interfaces detected by the software. So it works on selections of wall zones as well as interface zones. You don't need to define different interface zones beforehand. You can have only one wall zone or multiple wall zones, and they will all be detected. So in the boundary zone dialog box, if you click on the auto create and in the option and check on the 1-to-1 pairing, and then hit the auto create, it will create all these boundary zones showed at the bottom of the screen. So very easy to basically detect and define different interfaces. There's a GUI-based universal periodic creation. Now you can select any two boundary zones and then right-click and say periodic. And it can be conformal and non-conformal. The point is that if you select the auto option, basically the software would detect, in a smart way, would detect if they're conformal or non-conformal, and then apply the periodicity boundary condition to that. Overset meshing, there are some improvements. It uses less memory, a very memory efficient way now. And also there's some less restriction with the non-conformal interfaces. So before, if you had non-conformal interfaces, you could not have the overset mesh together. Now you can have them together as long as those non-conformal interfaces are not overlapping with the overset region, and then some turbulent transition models are now added to the overset mesh. The Adjoint Solver is kind of if you're familiar with that, it's an optimization tool. Now has some enhancement. It supports the autosave of case file and data file, and you can execute some commands when you use the Adjoint Solver. And finally, there are some updates in the graphics and post-processing. And this is one of, again, my favorite new features, is that if you just, a very easy way or fast way to change or color the surfaces with different select colors or variables. So for example, you can just right click in the graphics window on a surface and you say color by, and then variable, you can select the variable, and it's basically a contour generated on that surface, but it's very fast and efficient way as right clicking in the graphics window. The whole plane creation, surface creation has been I would say rebuilt or remodeled in the 2020 R1. It's now basically a new plane tool, and that you can easily play with it. You can drag the plane that you've created along the different axes, or drag it to the origin. And there's a dynamic display updating during all these manipulations. Different methods to create these plane surfaces are consolidated into one dialog box. Still, you have the XYZ plane method or point and normal method. In the 3-point method, there are bounded and sample points options, and which basically helps you to, if you select the bounded, the surface bounds are defined by the specific points rather than just the domain extension, and you will see that in the picture in the next slide. And if you select the sample points, it's instead of faceted surfaces, surfaces to be used for those sample points, you can create an array of the points. Basically. So that's what I was talking about. If there's this option on the top right, it represents the bounded, basically. If you switch it on and off, you will see the effect how it's basically bounded, not by the domain. So on the left, you have users selected 3 points, as you can see on the orange plane on the top left. If you select the bounded on, this plane would be bounded by those 3 points. And if you turn it off, this plane would be bounded by the actual geometry. And again, the center, kind of the middle of the screen, it shows those sample points that I mentioned. Instead of using faceted surfaces, it just uses an array of the points. There's also a new point tool, same as plane. It's got some new features. You can just easily drag it along the surfaces, or just a free drag in any direction that you want. There are 2 new plot types. One is called data sources, which combines different data from solution that you have, XY plots that you have. It can be XY plots, report plots, or any external data file. It basically combines all of them together, and it represents them in a multi-column data and files with multiple data selections. So a consolidation or a combination of different plots, basically in one source. This is something that is really plot, and this is something especially the aerospace or aerodynamic guys always ask for this. And this is basically, this example shows the whole thing. If, for example, you have an airfoil and you're going from the leading to the trailing edge along the that line, you can plot the cumulative force or moment data along this specific axis or this line. So it kind of acts as an integral function as you move along any specific line or axis. Some migration consideration. Probably the most important one is the cut cell remeshing method with dynamic mesh is not available anymore. And then if you're basically a Linux user, the RSH is no longer available to remote spawning the remote Linux nodes due to the security issues, and then obviously the secure one is the SSH method. And the T-poly utility is also removed. If you've used that before, there's some alternatives for that. You can look into it if you're interested. There's some documentation on this as well. And this is probably one of the important migration considerations, is that the case and data files are now written in the H5 format, which is a very more compact and efficient format. And they're called CFF, a Common Fluent Format by ANSYS. And they behave really well, especially in the panel. There's still an option if the user prefers to use the legacy format. So in the preferences dialog box, and you can basically switch between CFF or legacy, as you can see on the bottom of the screen. But again, it's highly efficient, so I would recommend it. We talked about the change in the viscous model. Default is no longer laminar, it's came on SSD. And the polyhedra unstructured mesh adaptation called PUMA is now used by default in 3D cases. And there's when you launch the Fluent in the launcher window, there is a section called What's New. You can basically refer to migration manual there, even more release notes, and lots of learning, basically, resources there. So I recommend you to take a look at that. So with that, I'm going to conclude this the Fluent 2020 R1 update. And you can feel free to type your questions here. We have a few minutes to address those questions. And if you have questions later, please feel free to reach out to us. You can call us or email us, and we'll be happy to basically answer your questions. Thanks for your time. Let's look at the questions, some of the questions that they have here.